In this lesson, we will cover questions from Unit 5, Section 5.7, Interpreting Graphs of Linear Functions. Question 1. Each graph shows distance, d in meters, as a function of time, t in hours. Which graph has a rate of change of 3 meters per hour and a vertical intercept of 2 meters? Before we can actually answer this question, we need to remember the terminology rate of change and vertical intercept. Rate of change is the difference in the dependent variable divided by the difference in the independent variable, which in this case is positive, so we're looking for a graph that increases starting from the left and moves to the right. The vertical intercept is the point where the graph will hit the vertical axis. And in this case, the vertical axis is distance, which is in meters. The easiest thing to do here is to look for an increasing graph to start off, and then we use the vertical intercept to start eliminating the graphs. As you can see, all the graphs, A, B, C, and D, all have a positive increasing line, which doesn't help us a whole lot. It's not going to help us eliminate anything. So we'll start off with looking at our vertical intercept. And we're looking for a vertical intercept of positive 2. So that must mean that our graph will hit at a point of 2. So that's what we need to look for. If it doesn't occur at a graph, then we can eliminate it. So this one here does hit at 2, but that is at the horizontal axis, which is time. And that's not what we're looking for, so that is gone. B, we're looking for a point that hits the vertical. It does not, so that one there is gone. C, this graph actually has an increasing line that hits at a point of 2 meters, so therefore that would be an option. D, of course, will not be because it is touching the vertical axis, but it does not have a vertical intercept of 2. This one here is 3 meters, so again we can eliminate that option. So our answer is C. We have an increasing graph with a positive rate of change of 3 meters per hour and a vertical intercept of 2 meters. Question 2. Sketch the graph of the linear function f of x equals negative 2x plus 8. This equation is actually in function notation. Since we're going to be working with the x and y intercepts to graph this function, maybe we'll rewrite the equation where it has just x and y to make it a little easier to recognize the intercepts. So we have y equals negative 2x plus 8. So first of all, we're going to find our x-intercept, where we have to let y equal 0. So we'll have 0 equals negative 2x plus 8. So when we do that, we're going to solve for the variable x. We'll have to first subtract 8 on both sides. So it's going to give us negative 8, which equals negative 2x. We'll have to use the inverse operation and divide by negative 2 on both sides. And this will result in a positive 4. So 4 equals x. When we find our intercepts, it's always a great idea to write it as a coordinate point. So here we'll have 4 and 0. And we're going to go over here on our coordinate graph and we're going to actually plot that point at 4 and 0. Next, we want to find the y-intercept. And we're going to let x equal 0. When we do that, we will have y equals negative 2 times 0 plus 8. So our answer here will be y equals 8. Which produces a coordinate point of 0 and 8. We're going to go over here now and find that. So we're going at 0 and we're going all the way up to 8. So 5, 6, 7, 8. And now we're going to try to draw our line through. Forgive me there, it's not a very straight line. But if you had to do it yourself, you would use a ruler to make a nice straight linear graph. So as you can see, this is a linear function with a x-intercept of 4 and 0 and a y-intercept of 0 and 8.